Unity 6.5 introduced a panel render component, which replaces the UI Toolkit component as the base runtime system for UI Toolkit. It has new features working towards in Unity 6.5 and 6.6 and 6.7 for animation support, SRP graphics, improved API, and a lot of other stuff. In Unity 6.5, if you want to see all the features and actually start getting fully featured working with it, you want to first go into project settings, go to UI Toolkit. At the very bottom, enable hierarchy integration. Do know if you're testing out 6.6 itself, you can also enable UI Toolkit animation to start testing out the new animation features. There'll be a video on that later. But just know if you enable that, you got to restart your editor before it'll take effect. You can actually create a new panel by, let's actually just go here. You know what? I think Unity actually created a, yep, they did. You can just go UI Toolkit panel renderer and it'll actually set up your panel renderer here. So notice inside the hierarchy, you have this none for UXML. So the panel renderer is just like UI document. You can just assign a UXML there and boom, it appears. Now, if I go back to hierarchy here, instead of that none, you can actually see your visual elements. And in the inspector, this is actually what the enable hierarchy integration does. You can actually start seeing them in the hierarchy, and you can also start seeing the resolved styles. You can see which ones are basically inline style overrides or style sheet overrides. You can start seeing the data source path and stuff like that, and start seeing the stuff like the attributes, like the text and so forth. Whenever you're actually using the panel renderer, you actually have to create a panel settings asset, just like UI document. For anybody that hasn't done that yet, you just create UI Toolkit panel settings asset. And inside here, you could set things for the default theme style sheet, the binding console log. So if you want to actually have warnings and errors appear inside your console whenever testing it out in editor, you can choose what kind of render mode, which is, world space or screen space overlaying. You can change how the UI scales when the resolution of the game actually changes. So constant physical size, pixel size, scale of screen size, stuff like that. You also have your dynamic atlas settings, clear settings, buffer management, and texture slot count support. Those are more for shaders. We'll actually get into that in a later video. But one thing you want to do if you are wanting to create custom styles, you want to create your own project theme or whatever kind of theme you want to create. Basically, it's the thing that holds your default style sheets and actually combines them. So if you go to UI Toolkit, there's a TSS theme file. If you actually click on the one you create, I would advise setting the Unity default runtime theme. That's actually the default UI style that Unity actually has for their visual elements inside the inherited themes. And then if you want to customize this UI in game and so forth, you can just add your style sheets to actually customize it there. The main reason why you want to do this, you don't have to set style sheets inside C#. You don't have to do any import commands inside like the USS style sheets or UXML for like setting the path. So you don't have to worry about any of that. So, and then after you create that theme, you just set it at the top of your panel settings asset. And then after you set your panel asset inside of the panel renderer, let's actually show this off real quick. If you notice, I named my panel settings asset player HUD. If I actually open the UI Toolkit debugger, if anybody hasn't used it yet, you can go to Window, UI Toolkit, there's the debugger option right there. There's a select a panel thing. If you notice, there's player HUD, and you can actually see my panel root. So whatever you name this panel settings asset is actually what the panel that is actually shown inside UI Toolkit is. And you'll notice here the root element is the name of the panel settings asset. And then you'll have panel renderer root element. This panel renderer root element is actually the start of this panel renderer. So you can actually start seeing there's my visual element, there's my label. Reason why I bring this up, you can actually have like child and nested panel renderer objects. So I'm going to create an empty child. I'm going to call it child rend. And I'm going to add a panel renderer to this as well. And I'm going to just add a different one. So if I actually go to the inspector, you can see the panel settings asset is set by the parent and cannot be directly changed. Since this panel renderer is a child of another panel renderer, the root panel renderer will set all children panel renderers panel settings. And if I actually go back to UI Toolkit debugger, there you go. You can actually see a panel renderer root and you'll notice that it's panel render root element dash player dialog, and player dialog is the name of the UXML. So you can actually figure out like what the name of the root element will be if you ever need to grab it inside C# or style it. And then you'll notice that dash and then the name of the game object. So player dialog is the name of the UXML, dash child space rend is the name of the game object, and then dash container. And same thing, if I actually just if I copy this real quick, you'll notice that there's, boom, again, child space rend and then parentheses with 1. So you can actually create nested group of child renders, and the reason why that might be useful, you can actually set sorting layers and sorting orders. For anybody that wants zdef, you can actually fake zdef with this, just heads up. Another reason is you might have, like, for example, maybe the panel renderer, like root is actually the in-game menu root. Like, I could say like in-game menu, and then maybe this child is like the inventory panel. Oh, I accidentally capitalized it in, but don't worry about that. Or then like another one is like settings panel. So you can actually have like the in-game menu, and then you can actually separate your UI into separate panels, and allows them to be much more controllable, much more manageable. So that's one reason why you might want children panel renderers, and why you might want the sorting order. So yeah. But anyways, now since we actually have those created, I have a mono behavior that I created, and it is just called player HUD demo. So I'm going to actually go to my player HUD demo, and we're going to talk about some of the API for this. So you'll notice that I have a serialized field called panel renderer. This is how you reference your panel renderer. Inside the on enable and on disable, I actually have the panel renderer checking if it's null. If it's not null, register and unregister UI reloaded callback based off if it's on enable or off on disable. And I'm calling a method called on UI reloaded callback. So this is where things start to heavily differ compared to UI document. In the UI document, you can just grab a root element. And the panel renderer, there's actually a UI reloaded on UI reloaded callback that you register and listen to. And basically, whenever the panel renderer is actually ready to show the tree structure of the UXML, so basically like the UXML file that you actually set, when this is actually ready to be used, then this is called. This allows you to make sure that anytime you're trying to do queries and actually try to like get a certain element and add a manipulator or like a register event to like button or something onto it, you know it's ready. So that is a huge difference between the UI document. In the UI document, you could actually get the root element before it was actually generated the UI tree structure, so you might get null references. Panel renderer, don't gotta worry about that. Do you know that means the panel renderer, you cannot directly get the actual like root element. So if I do like the panel renderer, there's no like root element or anything. You have to get the root element via this method, but that actually prevents a lot of bugs and a lot of headaches for people. You'll also notice that there's a int version. The reason why there's an int version here, the panel renderer catches the UI. And what I mean by catch, if I go in here and if I disable it inside play mode, if I actually go here and go into, oh, whoops, I forgot to set it. Let me actually set this. So if you actually set it, you'll notice that my debug.log version is actually here. And you'll notice there's a 1. If I actually disable the panel renderer, you'll notice that there's no longer a 1 appearing. That's because whenever you disable and enable the panel renderer, it actually catches the UI. And whenever it's re-enabled, if there is no structural changes done inside of the actual like UI tree, and just note, I actually realized I can actually get rid of one of those real quick. Gonna do that real quick. But ADHD moment, whenever you go and disable them, it doesn't clear the UI. It catches it. And that's why we're not getting this called again. But if you disable the game object and re-enable it, then it's called again. So as long as the panel renderer can actually catch your UI and doesn't have to like update it or so forth, your on UI reloaded callback might not get called back again. It might just catch the data, and that's good for performance. Sometimes whenever it calls this back, you might not want certain things to be done again. So let's say you have dynamic elements and elements being injected into it, like list elements and stuff like that. You might not want to have to, you might not want it to go through this again. So you can actually check the version and make sure like, hey, this version. Is this actually the same version? If not, then go through ahead. By default, you shouldn't have to check the version though, if you don't want it to redo it if the version hasn't changed, because Unity will actually not call this if the version change. The only reason why I have this here, there was a bug, but beta 9 looks like it's fixed it, so you guys probably won't even need this. But just know you can actually keep track of like changes in the version. So something to keep in mind. But yeah, and just to show this off, I have a button being added, and the button, whenever it's clicked, it just debugs logs the UI version. So just show this off. I'm going to disable it a few times. You'll notice that there's no debug log showing up because it's catching this is not being redone. But if I actually click the button, then it actually does like show that version 1 is still here, even though I disabled it and enabled it multiple times. So UI is catch. Keep that in mind whenever you're using panel renderer. That is useful because it prevents you from using stale UI elements that haven't been cleaned up in memory, and you might get null references that you weren't expecting. So it just helps with bugs. Another thing to think about, well, actually, let's go here first. If we actually go to panel renderer class, you'll notice it inherits from renderer component or renderer class. Renderer is the base class for sprite renderer, mesh renderer, skin renderer, all those kind of renderers. The reason why this is a good thing, this is a huge change compared to the old UI document. That means panel renderer actually will be getting support for SRP batching, different graphics things, and just know like if I can actually click the frame debugger here, and you'll actually notice that it appears here. The UI document used to appear too. But there's another thing now. If I actually go to UI Toolkit, or sorry, let's actually go to renderer. Oh, analysis, sorry. Render graph viewer, there we go. If we actually go to render graph viewer stuff, so many different viewer stuff to do. You'll notice there's actually more like draw UI Toolkit, UGUI overlay stuff. So you'll actually be able to start like using some SRP related textures and stuff inside of custom shader passes for like post-processing, custom UI filters, stuff like that. So there's a huge reason why panel renderer inheriting from just a renderer base class is a huge change compared to the UI document. Some of these features are not really usable right now from users in 6.5. 6.6 is adding more and more features that we can use, such as a really huge animation system. That's really nice. Like you can actually just open up the animator, add an animation clip, and you can literally choose any property inside it. Like if I actually go to animation here, and let's just go here. Yeah, blah, blah, blah. Just shove it somewhere. If I actually like go here inside panel render, you'll notice that, hey, look at that. I can animate colors and opacity already. So you have to have a panel renderer to do this. You cannot do that in UI document. It does not support it. So that's another huge thing about the panel renderer component and why you want to switch over to as much as possible. You can literally do tweening already inside the UI renderer. And for anybody wondering, there's not a lot of like properties here. I'm in 6.5. 6.6 added, I think like 60 properties you can animate. And I mean, there's a crap ton of properties you can actually animate in 6.6. There are some in 6.5, but 6.6 is the huge like animation add-on for the panel renderer. I mean, Timeline 6.6 came out, animation rigging 6.6 came out. Yes, there's actually Timeline 6.6. It is an animation rigging package 6.6. Those are actually built into the Unity as a core package, and that's basically going to be introducing the new animation thing. I don't know if I should talk about that. Yeah, we're doing that. But anyways, you guys get the idea. We have actual animation, SRP, graphics, feature support for UI Toolkit now. You haven't seen things, you can actually see them inside of the inspector. Do note, last thing I'm going to mention, I am going to be doing an entire video on this, but just showcase this. There's also a thing called visual element reference. And basically what that is, I can actually drag and boom, I can actually reference a visual element inside of the inspector now. So yes, we are actually working towards being able to just use like scene editing for visual elements. If I click a label here, you'll notice that at the current moment, the attributes and stuff are not editable, and even says like a reference up there. You have to like open them inside a thing. Unity 6.6 is going to be having a couple more stuff added, and you might actually start be able to edit the attributes just inside the inspector without having to open the UI builder. So you might be able to actually just do like the UGUI thing where you can just click on an element inside the scene and actually start editing inside the inspector. I'm not sure if they're going to get that fully ready in 6.6. 6.6 had a huge update to UI Toolkit. I probably should test it out after this video. But yeah, I don't want to go too much more. That's pretty much it. If you liked what you saw, if you liked me just rambling and showing new features for Unity, I have a lot of new features I could show, new animation tools. I could show different like rendering stuff for 6.6, 6.5. I can show a lot of new stuff if anybody's kind of curious about them, especially for 2D. Oh my god, I have so many things I could show for 2D. UI Toolkit and 2D anything is where I could show like crap ton of new features out. But if you liked the video, like, subscribe. I'm ending it here. I'll make a video. The next video will be dedicated just to visual element references and custom API that they have that really is useful. But thank you very much. Hope you guys have a wonderful day, and see you guys in the next one.